We're here as part of Florida Southern College's Foundations of Education 1 course, in which I, as a student, am going to give a lecture, and we are videotaping this lecture, and my lecture is on Piaget's theory of cognitive development. I'm going to be teaching this aspect of it, explaining it to these students, and since I am a high school mathematics teacher, this is going to be about how Piaget's theory of cognitive development, how it relates to teaching of mathematics in high school. So let me begin by introducing what Piaget's theory of cognitive development is. Piaget was a Swiss philosopher and psychologist who was born in the late 19th century. He died in about 1980. And in the early 20th century, he was a psychologist working with Alfred Binet. Alfred Binet is a psychologist who developed intelligence tests, IQ tests, and even today there's a very famous IQ test called the Stanford Binet. And Piaget was assisting Alfred Binet in marking and grading these intelligence tests. And these intelligence tests were given to children. And Piaget noticed in the wrong answers that the children gave that the types of wrong answers that the children gave varied with the children's age. And this led Piaget to develop a theory. Now, prior to Piaget's theory, it was generally thought that when the difference between adults and children, the difference between children and older people, was that adults have a lot more knowledge and a lot more information and a lot more experience than children. And that was the difference, a quantitative difference. The difference being an adult has a greater quantity of knowledge than a child does. A difference in the amount of knowledge they have in their brains. But what Piaget theorized was that that's not the only difference between adults and children. A very significant and major and important difference, according to Piaget, was that children and adults learn differently. They think differently. The difference is not just in the quantity of knowledge and learning that adults have, but in the quality, the how adults learn. And so Piaget developed this theory. And in his theory, there were four stages of learning, four stages of cognitive development that human beings undergo. And the first stage is, and these ages are approximate, but the first stage is from birth to approximately the age of 2 years old. For the first 2 years of a human being's life, Piaget called the sensory motor stage. And in that stage, the child up to the age of 2 learns about the world through using the 5 senses and through movement. The child learns through sucking, through smelling, through tasting, through crawling, through feeling, through hearing, through seeing, using all 5 senses of the body is how the child learns. And that's up to about the age of 2. Now, since we're dealing with teaching of mathematics, and particularly high school mathematics, we're not going to focus on the sensory motor stage. But after the sensory motor stage is the second stage, called the pre-operational stage. And in the pre-operational stage, that lasts from about 2 years of age to 7 years of age. In that stage, magical thinking predominates, motor skills are required, and the child is very egocentric. Everything is me, I. Children are always thinking in terms of themselves first. They are themselves the center of the universe. And at that stage, up to about 7 years of age, children cannot conserve or use logical thinking in any developed way. And of course, some children may end the stage at the age of 8, others may end it at the age of 6. 7 is approximately, in Piaget's opinion, when it would end on average. After that comes the concrete operational stage. In the concrete operational stage, that is a stage that lasts from about age 7 to about age 11. From that age, everything that the child learns has to be in concrete terms. That is, if you talk about something, the kid to really learn it has to see it, or has to feel it and touch it, or hear it. Everything has to be in front of the kid's eyes. Concrete. Okay? Something he can concretely see, touch, or hear, and if possible, concretely interact with it. That's very important. The interaction, concrete interaction. That, according to Piaget, goes to about the age of 11. After that concrete operational stage, we have the formal operational stage. That's from age 11 approximately up to adulthood. And in that stage, according to Piaget, people learn in a theoretical mode. They have the ability to learn abstractly. And what does this have to do with mathematics? Well, mathematics, especially higher mathematics, can be a very abstract, theoretical discipline. So, and here's the situation. In high school math, most high school math is taught in a theoretical, abstract way. Much of it is taught that way. But the problem is you have a lot of kids who are not yet ready on that level for the formal operational stage of learning. I'll give you an example. If I'm talking to adults about a triangle, I can tell them, oh, the triangle has 3 sides, the triangle has 3 angles, and so on and so forth. I can talk about the perimeter of the triangle is summing up the distances around the triangle, and so on. I can talk theoretically about a triangle to adults. With a child or somebody who's in the concrete operational stage, for them to understand and appreciate the word that I'm saying about a triangle, they have to see a triangle, or better yet, they have to hold the triangle in their hands, and they can manipulate it and interact with it. Or you can give them paper triangles and they can measure them and cut them up and play with them. Interact with the triangles. Okay, now, so what's the situation in high schools? I'm a high school math teacher, and I'm going to relate this to high school math. Here's the situation in high schools. The latest studies show, there's a study from 1998, I think it was Hewitt and Humboldt, shows that in the typical United States high school, in 9th grade, only about 20% of the kids are at the last stage, the formal operational stage of cognitive development under Piaget's theory. Only 20%. But in 9th grade, when the kids are about 14 years old, the typical 9th grader is taking algebra. Algebra is a very theoretical and abstract discipline, dealing with variables and x's and y's and equations. Now, it can be made concrete, but the problem is a lot of algebra is taught in this theoretical way. So you have a teacher teaching algebra to 9th grade to a 14 years old in a theoretical way, and 4 out of 5 of them, 80% of them, are at the concrete operational stage. There's a mismatch. The mismatch is between the way algebra is taught and the way the students are able to learn. They're able to learn in a concrete, operational way, and unfortunately, a lot of times, the subject is taught in a formal operational stage. Now, when I was a kid a long time ago, the teachers in teaching mathematics, it was basically just chalk and talk. The teachers had chalk, they used it on the board, and they talked. That's it. There were no manipulatives, very few pictures of anything. Everything was abstract and theoretical. And even today, even though we have more modern technology, it's still taught that way to a large extent in a theoretical manner. Now, and then, as I said, 20% of the 9th graders are in the formal operational stage, 25% of the 10th graders, 30% of the 11th graders, and 35% of the 12th graders. So each year it goes up about 5%. So this is the situation we have now with Piaget's theory of cognitive development and the teaching of mathematics. Any questions?
It's kind of the question you already answered. My question was, how do we apply this theory of cognitive development to the teaching of math?
Well, the way we apply it is we have to make sure that the way math is taught is appropriate to the stage at which the kids are at. And that stage can be determined by testing, but also we have to take into account their ages. So if the studies show that 20% of the ninth graders are at formal operational stage, they can learn theoretically, but 80% cannot learn theoretically, those 80% have to be taught concretely. And to teach them concretely, we have to use manipulatives. Today, we have computers and software, which we didn't have in Piaget's days. So kids can learn math on computers where they can manipulate things and interact with them, have a more concrete interaction. And the other thing is geometry, which is a study of shapes, is probably something that is amenable to more concrete teaching than algebra. So maybe it should be the case that geometry should be taught in 9th grade rather than in 10th grade. But the way we would apply Piaget's theory would be to avoid the mismatch. And when you have students who learn concretely, the subject has to be taught to them concretely. Any questions?
Yes, I have a question. What happens if Piaget's theory of cognitive development is not applied to the teaching of mathematics?
Well, when it's not applied, you have largely what's going on today. You have this mismatch. You have kids who can only learn concretely sitting in a classroom with a teacher who's teaching theoretically. And the teacher's teaching theoretically, the kids only learn concretely, they can't learn theoretically, the kids don't learn, and they fail math. And they don't get good at math, and they're not doing well, and they dislike math. And so, in Florida here today, half the kids who take the Algebra 1 end of course exam, the end of the term, for the first time, half the kids who take it fail. And to me, that's evidence that we're not succeeding at teaching them and not succeeding at learning. There is a mismatch between their learning abilities and how the instruction is delivered to them. And anyway, I think that gives you a taste, an idea of how Piaget's theory of cognitive development relates to the teaching of math, particularly math in high school. And I thank you for listening.